Welcome. In this tutorial, we discuss observability. Observability gives us visibility into our LLM application so you can understand what's happening, detect issues early, and continuously improve. There are many open source tools like Prometheus, Grafana, Zipkin. For this demo, we will not install any of these tools. We will use Grafana Cloud. Let's consider our AI application is in production, users are using it, and we have no idea what's happening because we don't have any traceability or observability implemented. As we don't have these, we have no idea how many tokens are being burned, which endpoints are slow, and where is the money going. Without observability, we are flying blind. AI applications need more observability due to LLM latency and cost involved in token usage. By tracking latency, cost, tokens, errors, we can lower the cost by optimizing prompts, reducing latency, improve errors by monitoring specific failure modes. Let's first create a free cloud account in Grafana. I will navigate to browser and I will hit this URL grafana.com auth sign up. If you already don't have an account, it will redirect us to create user. I already have an account here. So once account is created, add a stack. Click on the add stack, give a name here. I'll give Spring AI demo. Region is already selected here. I'll click add stack button. It takes few minutes. Now my stack is ready. If you click this button, launch Grafana Cloud, it will take us to Grafana dashboard. So here we have our dashboard. I will click explore button here. We can see our metrics. As of now, we don't have any metrics. Here we have different options. Make sure you have selected Grafana Cloud Prometheus. Let me go back to previous tab. We have to do some configuration here. I will click configure button of open telemetry. This is our OTLP endpoint and this is our user ID. Here we have an option to generate API token. I will click generate now. I'll give it a name Grafana or I'll change it to OTLP. I will not specify any expiry. We'll create a token. We have now token here. I'll close this pop-up. This is our API token, but we need this API token along with the user ID and base 64 encoded. This is what our API token plus user ID base 64 encoded. I'll keep this tab open. I will navigate to Visual Studio Code. We will configure dependencies and the properties. I'll open pom.xml. So here we will add our dependencies. So here are the 4 dependencies right now I have added. One is micrometer registry OTLP and micrometer tracing, open telemetry exporter. You might have used this earlier. Whenever you want to check health of your service or your application, we will be adding this dependency. Now I will open application.yaml file. We will configure the properties required for this tracing and observability. Management, endpoint, health, show details always, endpoints, web exposure. We need all these. Then properties related to the tracing enabled. Then metrics. So we have added here AI chat latency true. We can also add AI embedding latency true, but we'll just demo now AI chat latency. Now we add OTLP related properties. Here I will also add an endpoint property. I'll copy these property values from the Grafana cloud. So here is our endpoint and authorization. I'll copy entire this value of authorization header and I'll paste it here. Now we have our application.yaml file configured for metrics. There are 3 pillars to observability. In the metrics, we collect basically latency, cost, tokens, and errors. And the second one is logs. In the logs, we collect request parameters, LLM responses, user interactions, and error details. And the traces. In the traces, we trace the request from entry to exit, all the service calls, wait times, and dependency calls. Let's now build our custom tracer config. I'll create a new file here. I will name it tracerconfig.java. I'll annotate this with configuration. Let me inject some of the properties values from the application.yaml file. I'm using these three properties. First, authorization, that is our API token, and then endpoint, and this authorization token, and then application name. This we need to send it to Grafana. Now, let me first define the tracer bean. We use OTLP span exporter. So we have set the endpoint and metrics auth header here. Let's create an instance of resource with the service name. So we are using our application name as service name. We created a SDK tracer provider instance. Now we pass this instance to OpenTelemetry SDK and build the OpenTelemetry SDK object. We use our application name to set the tracer. Now we create a tracer context, also a SL4J event listener. Here we wrap the context storage to propagate OpenTelemetry context changes to SL4J MDC, and finally return the tracer. Let me go through line by line here again. Basically, this class wires up the full OpenTelemetry micrometer and SL4J bridge so that distributed traces are exported to Grafana and trace and span IDs appear in our application logs. Why this manual config? Spring Boot's auto configuration for tracing expects Zipkin compatible backend or pre-configured OpenTelemetry bean. Since we are pushing traces directly to Grafana Cloud's OTLP gateway, we are doing this manual config. This line creates the span exporter, the component that serializes the finished span into OTLP protobuf, and HTTP posts them to the Grafana Cloud's OTLP gateway. For this endpoint, we have to add v1 traces. This is a trace exporter. This is OpenTelemetry resource object, describes who is emitting the telemetry. Here we are giving our application name. So all the traces from this app appear under one service name in Grafana. So this line is the central hub that creates tracers and manages the span life cycles. It has two key settings here. One is batch span processor. This batches the completed spans and exports them in bulk. Default every 5 seconds or 512 spans. This is critical for performance. Without batching, every span would trigger an HTTP request to the Grafana cloud. And here, set resource attaches the service name resource to every span produced by this provider. The next line assembles the full OpenTelemetry SDK instance. The SDK is a top-level object that holds the tracer provider. So here it gets the tracer from the SDK. This is the bridge between OpenTelemetry's context propagation and Micrometer's trace context API. It allows Micrometer's tracer to read and write the current span from or to telemetry's thread local context. Here it listens for micrometer tracing events and writes that trace ID and span ID into SL4J's MDC. The last line, which constructs and returns the final micrometer tracer bean. Now let's create a OTLP meter registry bean. Here we will create OTLP config object. Let me accept this coding suggestion. We will make changes wherever it is required. I will also override resource attributes method. I'll set this application name here. This is not endpoint, it should be URL. That's why the error we have. If you look at here, we are appending base OTLP URL with /v1/metrics. In the earlier one, we appended /v1/traces. this config is complete, let's create a controller class. Let's name it observability controller.java. I will annotate this with REST controller, a base request mapping /AI/observability. I'll define a logger, then a private field for chat client and for meter registry, a timer for measuring latency, and a gauge for tracking active requests, and a distribution summary instance for tracking token related metric. Now let me create a constructor to inject these dependency beans. So we have chat client builder and meter registry, which we just defined now here in the tracer config. We inject chat client and meter registry. We build a timer object to track AI chat latency. We add this description here, time taken to get LLM response, and with publish percentiles and register meter registry. And we create a gauge object here for tracking active requests, and we build distribution summary object for AI tokens used. Now I build a helper method for estimating the tokens. I'm using rough estimate here, one token equal to 4 characters. I'll define a get mapping to demo this matrix. Let's define the method signature, which takes a string parameter named message. In the first step, let's increase the counter whenever we get a new request. Also, we update active requests. Now let's define a try block, also a catch block, also a finally block. So in finally block, once this request is completed, we will remove it from active requests object. Now here in this, we use chat latency object and we call record callable method. We create a lambda expression. Within that, we define a try block again. Inside try block, we call LLM, that is usual chat client dot prompt dot user dot call, and extract the content. I'll save this response to a string variable. Once this response is received, we will update meter registry counter of name AI chat success. We'll increment it. Now we call our helper method to estimate the token, and we record it in our token count object. Let me log all these details, then return the response. And in the case of exceptions, we increment the counter of AI chat failures. Now we add a return here. Let me add a semicolon. It should be throw new runtime exception. Now our implementation is complete. Let me build this and run. Let me bring up the Postman. Here I have already added this chat observability chat observable API, which is a get API. I'm passing a message, tell me a highly obscure fun fact about coding. We have added this matrix here, AI chat latency, AI tokens used, AI active requests, AI chat failures, AI chat success. So in our Grafana dashboard, if you click on this Grafana Cloud Prometheus, now we don't see any metrics here. Once we hit the API, we should see some metrics over there. Let me hit the API and wait for the response. So we got the response here. Let's look at the logs as well. So this chat completed, tokens estimated, response latency. Now I will navigate to the Grafana Cloud dashboard. Let me refresh this page. Let me check if I have those metrics now. We can see these metrics, AI active requests, chat latency here. So for every metric we add, it will add 3 types of metrics here: bucket, count, and sum. So if I select this count, we should see one request as of now, because we hit API only once, here it is. We have now our metrics in the Grafana. Also, let me look at other metrics. I'll use token used sum. I'll run the query. So the tokens used is 271. Let me also look for the AI success and use the query. So there is one success request. And if I look at failures, so failure is not added at, as we don't have any failures. Once the request fails, then only we add. So we don't see as of now in the Grafana the failure metric. Also, as we have added the actuator dependency, we can look at this API. We get all the metrics available. If you want to see in-memory values, you have to hit this API, actuator metrics and AI chat latency. Let me hit the API. Here is the latency value. Similarly, you can check for these metrics as well. This is Gen AI client token usage. What we have here is AI tokens used. Let me try to get this value. So it is 271. So if we look at this metrics in Grafana, let's go back to browser, and here I look for Gen AI token usage total. Let me use the query. What we got here is 484, and if you look at here, I think this total count should be 484. So if you look at here, AI token type, this is input tokens consumed, these are output tokens, and this is total of these two is 242. So when we use GenAI total count, it's giving us 484. We will wrap this lesson here. In the next lesson, we will look at structured logging. We'll see you there.